Okay, but yeah, like I said, this needs to slide up and down those tracks, so you know it's nice to not have sharp corners. So again, just to be safe, again, it's just a proof of concept too, so just to be safe, you know, this is the best way to do it. You know, of course, if we're doing an injection molded part, I could do it on both sides. I could, you know, fill up both sides with no problem. Because this part here, you know, that we're doing is eminently injection moldable, and you know, if you think of a parting line, for example, you know, running right along through here, you know, we have this part here, you know, which is going to be, it's got to be right there. You know, this has got to be actually aligned exactly with the bottom, because again, it's 3D printing from the bottom up, and it can't print in free air. You know, that's why I can't put it up here, because guess what? You know, it would start printing the base of this layer by layer, but when it gets here, well, since this is going to project out, it would be trying to print in free air. In fact, let me go ahead and show you that. I'll move it up here. An elevator here. Okay. Trying to figure out where I'm at here. Well, I'll just put it here. What the hell's going on here? Something's off center here. There's a ring. What the hell's this? Oh, I guess our our diffuser had slipped. I got carried away with it. Let me recenter it. I don't know if that recentered it, because I don't think I centered on it. Okay. There we go. Alright, now it's aligned. Okay. Alright, so I put our little profile right there. Now the question is, like I said, that would be the inner wall thickness, and this is the other reason the wall's got to be thick too, because I got to put this little track guide in it. You can see where our inner wall of our ring comes to, but this track, you know, we need to extend into this way, and I'm going to try to keep everything thinking straight, but I don't know. I mean, I might want to make it curved. Might want the inner part to be curved, in which case I may want this to be curved as well, but we'll deal with that in a minute. Okay, so you know, this circle here represents the inner wall. We don't want it going in that far, because it would basically be penetrating the tube. And this circle here, if you recall, is the outer wall. So pay attention to the edge right here where the cursor is. That's the critical part, because again, I'm going to go ahead and pull a curve on this. So, but we got to have some tolerance to it. But we want, see the distance here, from here to here, you know, 79 mil to 109 mil. So that's like 30 mil, right? We want this to be certainly greater than 30 mil, in case, you know, like for example, if we did actually go into production and they made it precisely this way, we wouldn't need this loose of a tolerance on it, you know, if we went and had this injection molded. but let's say we did, for some reason or another. We want this distance right from here to here to be greater than this distance from here to here, so the thing at least won't come out of its track. Because see, the fact of the matter is this cylinder here will probably be fatter than this, by, for example, something like that. That might be the actual distance, and this will probably be thinner than this by a similar amount. So this could be our actual clearances on the 3D printed part. However, when if we went to production with this, well, this might be the actual clearance, which is 30 mil. Well, remember, it's actually 60 mil because this can actually come out, from side to side. So this could come out of the track, if we're not careful. So we want to make this part here extend as deep into this as possible, to account for that, so like I said, for a 3D printed part it might work fine, but for a production part, if we just willy-nilly either forgot to change it later or whatever, or this was some different area of the design and we really couldn't take the risk of changing it for some reason, we want to make sure that we got as much of a tolerance here as possible. That means this needs to come as deep into this as we can. So like I said, given the fact that we're looking at something along this line here, and this is the outer, this circle here represents the outer shell. Okay, notice I'm looking at our measurement down here. 60 mil, it had to come this deep just to handle these possible clearance errors that could be in it that could cause something to slip out. Because like I said, if this inner tube was shifted another 30 mil this direction, well, this thing would come out if it was only 60, less than 60 mil wide. But we need it greater than 60 mil. So, in other words, it needs to come, I'd say at least 75 mil or so. So needs to come at least, what the hell? Oh. But it needs to be at least that long. So, basically, let's extrude it to that, and my little constraint, these are where you set the constraints on it. This means it snaps to the end. That's where you set your snaps. That's near, that's point, that's the middle. So we'll find the middle of something like where we're at right there at the mid. At any rate, I'm using my end snap right there to snap to the end of that line we made. This should be deep enough, but now what I need to do is I need to, because I want to keep this thing circular. And see, this right here may dictate that we might need a thicker wall for this particular design than we actually have right now too, because we're starting to get pretty thin here. Oh, yeah, I don't have this thing aligned yet. Let me align this first. Okay. Alright. Let me draw a circle here and basically extrude this down, and let me do a Boolean subtract from that. Okay. Alright, so what I did was let me get rid of this battery. I created, we got a slight curvature in that face there, so it follows the curvature of this. But remember, we're still going to need tolerances even on this. So But it actually doesn't, I didn't realize that, but it actually doesn't have to, because what we really need is we need it to be over 60 mil from here, actually. Shite. Come on, turn, if you press control, it turns those snaps off so they don't get in the way. But actually, it needs to be like 60 mil from here, not 60 mil from the other dimension. So we can actually go in that far right there. It doesn't need to come in as far as we have it. So let me go ahead and redo that circle then, with that in mind. So take that and subtract it from this. I don't need this one anymore. What the? To move it up. Okay. There we go. I don't need this anymore. Or that. Okay, so that'll actually put us in pretty good shape right there, because remember, like I said, if this circle were to move down here in a production design, this would still be captured, inside the housing. It would not come out of its track, and that's what I'm trying to make sure of here, so we don't have that happen. Let me try to figure out what that is. That's nothing we need. So, okay, so that gets basically that done. I'm going to delete that. We don't need it right now. But like I said, we are going to need a, when we do our track, our track is going to have like a 25 mil or so, or really 30 mil, the same as this. It's going to have a tolerance for error in it. So so it's going to have to be along the lines of that. Which, like I said, this was the inner wall of our thing. Which, if you recall, comes there. I don't remember what this circle was, so I don't think we need it anymore. But this right here, I'm going to put on a different layer. So it's a different color, so we'll remember. But that should be the inside of our track when we do our track. And this is the inside of the wall of the housing. That's the outside of the wall of the housing. So when we go try to carve that in, we're going to need those reference points. In fact, I'm going to go ahead and move these to. I've got to rename these layers. Well, just let's see. Maybe do something like that. So that'll be our. We'll call it. I don't know. Upper housing. Because I get all these things arbitrarily named here. Call this lower housing. And I know we're going to have a top, so we're going to have a top, and there'll probably be some kind of an electronics interior too. So do something like that. I'll go ahead and turn off that circuit board. Well, this is the ring. Okay, so that's what we're going to be working on right now, is the ring. That there and that there. Okay, and then let me take this and we'll stick it on this lid layer here, because that actually is the lid. That inner track, and let me start a new layer here. Call this diffuser. We'll move that to the diffuser layer, and let's get our basic layer structure set up there. So that way, if I want the diffuser out of the way, or the lid out of the way, I can just hide that layer. So while I'm at it, now let's get back to the issue of why we got to put this part on the bottom here. You see that right there, you know, if we were to print this thing, layer by layer, it starts from the bottom, and it'd be actually trying to print this overhang in midair, and it can't do that. Now, without some kind of a, you know, either a support structure built onto it, which, like I said, is a recipe for disaster with an untweaked printer, or without there being some kind of chamfer or something under it. But this is why I've got to take this sucker here and move it to the very bottom, because the printer cannot print in midair. Let me get rid of this outline. Anyway, but that is the thing we're looking for, the shape we're looking for. So let me go in here and create a polar array. Delete this, we don't need it. So we got 3 of those, and let me go ahead and grab these and see if I can weld them together. Alright. Because these need to be, you know, when you generate your STL files for 3D printing, they've got to be one part, otherwise the thing just doesn't quite work right. It'll confuse the printer. You can't just print, you know, I couldn't just leave these as independent parts, because if I did, what would happen is the 3D printer would actually be trying to print inside of this other part while it's trying to print this part. So, needless to say, it would really cause chaos. So, you know, that's why I got to use these Boolean operations, you know, to try to form this. Any part we make is a single part while you're 3D printing it, because otherwise, you know, you can run into trouble on your print. That's why anytime you're printing a part, you know, in fact, let me go back and show you this, just to be clear. If this, you know, if I just left this as it is, you know, you have this part and this part, okay, you know, you may import it into your 3D printer file and everything looks good to go, but in fact, you've got these 3 separate parts here, you know, here, here, and here, plus this ring, they're actually overlapping each other. So this thing, we treat this as a separate part and go try to print the thing, and not realizing that it's actually running into another part while it's doing it, and try to print this, so you end up getting more plastic built up here than is supposed to be here. So basically it's going to end up gooping everything up, and it'll probably make your 3D print fail. That's why thinking ahead about how a 3D printer works is very important, because that's why I've yet to have a failed print, even though I'm relatively still new to 3D printing, because I'm thinking about the process when I'm doing my designs. The only failed print I had was that blue thing that I printed out that time, and that's because the filament was bad. But this is a surefire way. If you want a failed print, do it like this without combining these into a single part. If you do, you're definitely, almost certainly going to have a failed print, because it's going to be trying to print 4 overlapping parts on each other, and you don't want that. But see, this way, it's no longer got that overlap. You can see that we had before. So it's treated as a single part, so when you generate your STL file, it's just going to have a single part. It's not going to try to print one part overlapping another one. It's like some of those sci-fi movies, when you see something materialize in something inside of something else, well, it's not supposed to do that. So, all kinds of bad things happen, and I'd imagine with a 3D print it could, because I don't think most of the software is intelligent enough to realize that. I could be wrong, though. It might actually do it just fine, but to me, my instincts tell me that could be a big problem if you just imported it like that. By all means, you're welcome to try, but it could create a real mess, if you don't want to do Boolean operations for some reason. Either you don't have the software for it or whatever. But it's just a good idea that anything you print be a single piece. From a digital standpoint, it'd be a single piece. So anyway, that pretty much gets us our holder. We've got the our 3 guides for our forthcoming track and the housing. We got our containment for our cylinder here. So that's pretty much what we needed, and we do have our LEDs all laid out in the rough pattern we're seeking, and our diffuser more or less taken care of. So again, that gets us going on it.